To help understand confidence intervals, we look at the normal distribution of the density curve, or also known as the 68, 95, 99.7. These help determine how much percent of the sample size within the spread of the first and second and third standard deviation away from the mu, our given mean. If you notice the first standard deviation away from the mu, first standard deviation, has a spread of 68% of the sample size given altogether. And by adding another standard deviation, it raises our spread of 68 to 95, and by adding a third standard deviation, it raises it to 99.7%. And that is a way to understand confidence intervals within standard deviation in your mean.
What does confidence intervals help us do? It works for estimating the value of a population parameter, which is based on sampling distribution of statistics. When you use statistical inferences, you are acting as if the data are a random sample or come from a randomized experiment. A confidence level C, which gives the probability that the interval will capture the true parameter value in repeated samples. And the interval is exact when the population distribution is normal and is approximately correct for large N in other cases. The estimate based on the sample is the center of the confidence interval.
To calculate confidence intervals, you take the confidence interval formula, which within there you need to know what the sample mean is, the z-star, standard deviation, and your sample size. So first you take your given information, and you need to know which z-star, what percent of z-star you use. So for this equation, we're given our 15 sample mean, and our standard deviation, and our sample size, and it asks for a 95% z-star. So to calculate it, first we need, use your calculators to divide standard deviation, which is 3.2 divided by the square root of 200, which that equals out to be 0.2262, which equals out to be 22.62. And then when multiplied by the 95% z-star, which is 1.96, it equals to be 0.4435. And that is what you're trying to figure out for this area right here. Now, all you have to do is add and subtract it from your sample mean, which, when you take 15 plus 0.4435, it equals out to be 15.4435. And then when you subtract 15 from 0.4435, it equals out to be 14.5565. And by finding what these two numbers are, you figure out how big your spread of your confidence interval at 95% is. And this helps shows, those two numbers help show your 14.5565, then your x, and then your 15.44. And this helps you find what the probability of 95% is. You're going to find a sample of within the standard deviation of that. So this shows your spread of how much 95% of your sample size is. This is the end.